Good afternoon and welcome to week 2 of module 2. Today we're going to talk a little bit about databases and data cleaning because we've begun to design our research protocols, and something we need to think about is how we're going to collect the data and where we're going to store it throughout the course of the research project. So our learning objectives today are to learn about a couple of different database options, to discuss primary data collection, to discuss standardization and cleaning of our data, and understand the importance of keeping a data log throughout the course of our research project. We're going to look at the available databases and really focus on just 3 to 4 of them, but there are definitely more available to you. We're going to talk about what you should do and general ideas for primary data collection. We'll talk about data management and data cleaning. When we think about databases, we want to think about something that's going to be feasible to use in our clinical setting or in our research setting. And there are a couple of databases that come to mind. But first, we want to talk about what is a database. A database is an organized collection of data generally stored and accessed electronically from a computer system. Why do we use them in clinical research? We use them to capture and store patient and clinical data, which can be used to answer your research question. When we think about the different types of databases available to us, one of the ones most commonly used in research is Excel. And this is just an example of what an Excel database can look like. Every database has benefits and disadvantages. And when we think about the benefits for Excel, it's affordable, it can be used offline, and can be exported into statistical software. When we think about some of the limitations, it's a type of database where there aren't necessarily privacy protections built in, so you have to be cautious about where you store your patient data in order to make sure you're adhering to the ethical principles of keeping the patient data private. And it's very easy for data to get disorganized on an Excel database. Kobo Toolbox is another database that has been designed for research in areas where internet access isn't always available, and has a number of different options, including designing a questionnaire and recording it on your phone offline and then uploading it to the database once you have internet access again. So some of the benefits of Kobo Collect is that it's free, it can be used on mobile phones or tablets, it can be used offline, and it can be used for qualitative studies. Some of the limitations are if you're going to be collecting photos or file sizes that are very large, sometimes that takes a little bit longer to download or upload to your database. And you do have some limits with regard to the types of servers that you're using. We also have Google Forms or Google Surveys, which is another type of database that you can use. This is an example of our course evaluation and what it looks like on the Google Form side. This would be something that you would send to people that you're surveying or send to your data collectors and have them fill it in from patient charts. And this is something that you would get on the other side, which it actually creates your database for you. And you can see that each of the questions turns into an Excel column, and these will auto-populate once people have completed the form on the other side. So it's very handy to use in that regard. Google Forms and Surveys are also free. Again, these can be used on your mobile phones or tablets, and you can design them yourself. They are easier to use with reliable internet, and they're not always the best for patient privacy. There's no built-in privacy protection, but you can design things in your Google Form or survey that make sure that only people who are part of the study have access to the data on the other side. And then again, if you don't give pre-specified answers, it's very easy for your data to get disorganized, and that will make it difficult to analyze in the future. Another type of database that's very often used in clinical research is REDCap. This is just an example of a REDCap form for a study looking at marital status, and a study looking at women who are having C-sections. And this is just the first 4 fields. One is the study ID number, the age, the sex of the patient, whether they're married or not, and then for the woman, whether they've had given birth before. And you can see that on marital status, REDCap allows you to pre-specify fields. And so each of these will be sort of coded before you go to analyze your data. And REDCap has a lot of benefits in that it allows you to store patient data securely. It keeps all of your data in one place. You can export your data very easily into statistical software, and the data can be shared in multiple locations at once. So REDCap is often used in like research consortiums where you have 10 to 12 different institutions doing research on the same subject, and everyone can enter their data on their specific patients, and then you have all of it in one place when you go to export it. And you can also grant different levels of privileges. So if you're the primary investigator, you can have access to all the data. If you want the data collectors only to be able to enter data for their specific patients, you can do that as well. And there's a lot of different things you can do with the REDCap database. Some of the limitations is that you need institutional access and it's not free to use. You need internet access to do a lot of the data exporting, but you can enter some of the data offline. And then finally, usually you have to build your own data collection tool, and this can take some time to learn. When we think about data collection itself, we need to think about the life of our data. And so there's a couple of different ways that you can get data. You can do primary data collection, which is a lot of what we'll be doing in this research course if we're doing a clinical research study. And you can have data that's given to you, so something that's exported or pre-collected, and you can use that. And both primary data collection and existing data kind of take you to the next part of how you think about the life of data, in that once you have data, whether you collected yourself or you were not the primary data collector, you will then have to clean the data, manage it, and then perform data analysis. So first, let's talk about primary data collection. Before we start talking about that, it's really important to document any decisions and changes to your data as you move throughout this process. So as we go through the rest of the lecture, we'll just remind you that documenting what you change and how you collect data is very crucial to remembering and being as accurate as possible throughout the data collection process. So just to take a step back and remind ourselves that when we think of data, there's a couple of different types. There's numerical, and within numerical, we have discrete and continuous data. And we also have categorical data, which can be broken down into nominal or ordinal data. And so it's important to think about what type of variables you're going to collect and how you're going to categorize them, because numerical and categorical variables can be inputted differently into different data collection tools. When we think about designing a data collection tool, we want to think about something that will allow us to answer our research question and will collect enough data so that we can answer that question. This tool can take the form of a questionnaire like we talked about on Google Forms. You can ask for very specific things from your data collectors or from yourself if you're doing the data collection. This tool can be in the form of an Excel spreadsheet, as we've seen, but as you design the tool, it's really important that you try to minimize ways that you can have errors in data collection, and we'll talk about where these errors can sort of be created throughout the rest of this lecture. You don't have to be super stressed out about designing this tool by yourself. You're going to work together with your mentors and your teams to design a data collection tool that's unique to your study. So we'll talk about basics here, but we'll really get into designing the data collection tool as we work together in our mentorship teams. Just in general, when we think about a database structure, in general, whether you're using Google Forms or Excel, we typically think of rows as different patients and columns as different data variables that we're going to collect. So here's an example where we see each row, it represents a different patient, and each column represents a different variable looking at mortality for surgical procedures. And in this example, one variable is gender, one variable is age, which would be continuous, another variable is a surgical procedure, this would be a categorical variable, and then death is the last variable. When we look at data collection, the first thing we need to do is determine the variable format. So think back to what type of variable you have, whether it's a nominal variable, a discrete variable, or continuous variable, and that will kind of help you decide how you want to standardize it for your data collection tool. And then you want to really try to standardize as much as possible because this will make it easier to work with in code later. So if you're talking about gender, two examples of way to standardize that is you can use female or male, and if you wanted to include binary and non-binary, you could as well. And again, every time you make a decision about how you're going to collect a variable, it's important to keep that in a data code book while you are designing your database, so that if you move forward and you're asked to look at this data again, 2 to 3 years down the line, there's a very clear history of what's been done and why. In addition to thinking about the variables themselves, it's very helpful to think about how you're going to code the columns, either in the Excel spreadsheet, on REDCap, or on Google Forms. And you kind of want to compromise between length and understandability. If you just label your columns question 1, question 2, question 3, and you look back at it 2 years later, you may not know what that actually means. If you are using a survey and you just include age, sex, or marital status, you may not know what question that is. And so sometimes it's nice to combine them and say question 1, age, question 2, sex, question 3, married. And so you can very quickly go back and either go by the number of the question or by the variable itself and identify it when you're looking at your database. So just as an example from our prior one that we used looking at surgical procedures and mortality, if we wanted to compromise and we were doing a survey, the question 1 would be gender, question 2, age, question 3, surgical procedure, and you can see that we've shortened it so it all fits in one line, and that'll make it very easy to look at in our database. And then question 4 is death. When we also think about collecting data, it's important to think about categorical variables. And a great example of this is how you want to record categorical variables the same way. One of the examples of how this can get messy can be seen with surgical procedures. So in surgery, we can use abbreviations, or we can capitalize things, or use 2 words for a procedure that can also be described using 1 word. And then if you were to go and look in your database, you'd see 3 different descriptions or 3 different ways to enter data for the same procedure. So if we think about exploratory laparotomy, that can also be labeled as laparotomy, or it can be shortened to XLAP. And so if all 3 of these are in your database, then this could show up as 3 different procedures, but it's all the same one. So it will be difficult when you go to try and pull out all the laparotomy cases for your analysis. So remember to record data the same way and to capitalize words the same, because in some databases, the way the word is capitalized may prevent it from being separated out when you filter in Excel or on Google Forms. So remember to use the same procedure names and capitalize the words the same. And one of the ways that makes this very simple is you can actually provide specific choices in your database so that the people who are entering the data, whether that's yourselves or a data collector, don't have an option to put it in the incorrect way. And if you think that there's an other category, you can include that as well, and then people can hand type in that other themselves. So if we think about how we would do that for, say, different specialties of surgery, this is an example on the far right where we have 12 different specialties listed, and we could have other, and people could enter an additional one if that's what they thought was needed. But this allows you to only select from urology, orthopedics and trauma, neurosurgery, thoracic surgery, and then that will filter into the spreadsheet itself, and you don't have to worry that one of the specialties has 2 different names in your database. Again, here on the left, we can see that if we wanted to look at mode of arrival, if we wanted to see how people were coming to the hospital, we could have 6 different options for them. And here we don't have an other, so they would have to choose between one of these 6. And again, this makes it very simple for data coding and analysis in the future. So an example of data collection is when we look at back to our example, when we're looking at gender, we could enter female, male, and female. And again, these could be pre-assigned, so there's no error there. When we look at age, something to think about if you're using a continuous variable like age, where you can have it in months or years, you'd really want to specify what you're collecting in your data logbook. So in this instance, we're using years, so 0.5 would equal 6 months. So if you're using months, the numbers would be different. And this is an important thing to think about with continuous variables. And it's important to note the measurement you're using, whether it's in millimeters, centimeters, age, month, or years or months, and things like this. So that would be important to include in your data code book. When we look at surgical procedure, we can see that everything is capitalized, every word is capitalized, and we use the same term for exploratory laparotomy for patient 1 as we do for patient 3. And then for death, this seems a little bit simpler, but no and yes. And again, everything is capitalized just to keep it very standardized across our database. We've talked a little bit about how to think about primary data collection and how to think about your variables and the importance of keeping track of how you design the variables for the data collection tool. And now we're going to talk about once you're actually in the data collection process, whether that's yourself or a data collector. A lot of times you have to sort of manage the data as it's being collected. So we've talked about primary data collection. Now we're going to talk a little bit about management. And so one of the things that you want to do as you're collecting data is validate that the data you're collecting is actually accurate. So this is something we're going to go through and check throughout your project to make sure the data being collected is being recorded accurately. And it's good to do this for yourself and if other people are collecting your data. So what you're going to do is look at your database and choose random patients or rows to compare to a real chart if you're doing clinical data. If you're doing a survey, you'd want to compare to the real survey document, and you want to look at columns of data for missing values, incorrect values, etc. So when we think of an example of data validation, these are the random patient charts that we've chosen to look at. You can see for patients with the ID of 3, we can see that all the data is entered and it looks like it's almost all correct, except for we look at sex and we see an M instead of the code. So we'd want to go back and verify that that M is actually in the right place and the patient is actually male. And then we would code that as a 0, 1, depending on what that code is in our logbook. When we look at patient 11, we see that most of the data is entered except for the data in the final column. So we want to go back and verify that that data did not exist in the chart and that that is accurately recorded. And same thing for patient 17. And again, this is something that we're briefly introducing here, but as we go through the data collection process, we'll work with our mentors to learn how to validate the data and do this ourselves. Now that we've talked a little bit about data management and validating that the data collection is going well throughout the data collection process, typically you'd want to do this, 2 to 4 times, depending on the length of how long your data collection is ongoing. We want to talk about once we have all of the data in our database, how do we clean the data? So whether you primary collected the data yourself or you got a database from someone else as part of the study team, you're going to end up cleaning the data at some point. And so we're going to talk a little bit about what cleaning data means. Before you start cleaning data, it's really important to save an original and a backup of the original data that is untouched. So you can always go back to that if there's any question later on during the data analysis period. And then you want to create a folder for each phase of the data management. So you have your clean data, your data analysis, and any imported data that you may have gotten from another location. So when we think about cleaning our data, let's look back at our example and see just our primary original data and think about what we might want to do to clean that data. And as we mentioned, one of the things that you can do is assign numerical variables to variables that are sort of nominal or ordinal or categorical. So if we look at gender, if we want to assign variables to them, we can assign a 0 or a 1 for male or female. So in this example, we assigned a 1 to equal female and a 0 to equal male. And you can see that we replaced that in our original data set. And now we want to go to our logbook of what we're doing with our data and describe this. So this is an example of the data documentation log. So we started with our original data. We had X number of patients. We collected this data on this date. If we excluded any patients because they didn't complete data, you'd want to list that as well. And then you can see that we coded male equal to 0 and female equal to 1. And then we saved the file as clean data, and then you would list the name of the file and where you saved it. That will help you stay very organized. So then, now that we've learned a little bit about coding data into numerical variables, let's look for ways that we can see whether data is clean or where it can be improved in another data set. So we want to look for invalid values, values that are outside of the normal range, values that are missing, or values that aren't coded correctly. So if you look over here on the right, you're looking to see if anything appears out of the ordinary or if it isn't coded correctly. And we see again here that there's an M under sex, and this has all been coded as 1 and 0. So we can go back to our logbook and say, we know that male is supposed to be coded as a 0. So we would replace that to make sure that all of our data is clean. We'd also probably infer in this instance that it should be a 1, but you can always go back, and you should go back to your original data collection form or the patient chart to make sure that that is accurate. If you can't find the original data to make sure that it all is coded correctly, you can leave it as missing data, or you can try to infer from other variables, but we'd caution you on inferring and really try to go back to original charts as much as possible if your data has an error or is unclean. The other thing you want to do is make sure that there's consistency across your variables. So for example, if you're collecting data on whether a person smokes and how many packs per day, these would probably be 2 different questions, and these would be 2 different columns. So in one column, if they say that they're not a smoker, and then you go to the column that asks them how many packs a day they smoke, and it's greater than or equal to 0, you know that there's some error there, because if they're not a smoker, they shouldn't smoke any packs per day. So this is something that if you have multiple columns that go together, you want to double check that the data makes sense in both columns. And then you want to, again, use really consistent use of values, so 0s and 1s. If you're using 0 for male in one column, you want to use 0 for male in another column if it is comes up again in a different variable. And then if you're going to record missing data, try not to use values that might be included in other data columns. So for example, if you're collecting data and it's a continuous variable from 0 to 1,000, then you don't want to code your unknown variables as 999, because that is something that could be included within that data collection of 0 to 1,000. So you can use a dot. A lot of times people do use 999, but you just want to make sure that it's not already included as a potential variable in your database. And then if you have a really large database, sometimes your data is never going to be entirely clean. So you want to decide when your data is clean enough, and that really depends on what you plan to use for your analysis. So in our research protocol, we're going to very clearly outline what we plan to analyze and how we plan to do that with which variables we're going to collect. So these would be the variables that you want to focus on cleaning if you have a very large database. And then you really want to see where the data entry errors will impact your analysis and how they'll impact your analysis. So in summary, we've talked a little bit about primary data collection. I think that's something that's a little bit difficult to describe for every study. It's something that we'll work on together in our mentorship teams to design a good database, to figure out what variables and how we're going to allow them to be entered into our different databases. We've talked about what it might look like to get existing databases. We've talked a little bit about data cleaning and coding each of the variables into a numerical code, which then will be used for statistical analysis, as we'll see in the future. And we talked about data validation and data management and how we should check in with data collection and verify that the data that's being entered into our database actually coincides with what is in the chart, and that we should do this on a 2 to 4 times depending on the length of the data collection. And then in our next lectures, we have another lecture next week that's going to start to talk about different statistical analyses that we can do, and that's when we'll get into data analysis. And in summary today, we learned about different database options just briefly. We'll explore them more as we pick them for our specific projects. We discussed the standardization and coding of data, And we now understand the importance of keeping a data log. And in general, probably the most important thing that we can stress to you as you go throughout collecting data is the importance of keeping this log and staying organized and documenting what you do throughout the data collection process and throughout the data coding process. Because if you have this, it doesn't matter how long you keep the data, and when you go back to analyze it, you can clearly go back to the data log and make sure that everything is described there. We know that not everybody is familiar with Excel, and we anticipate that Excel will be one of the databases that we use frequently across the mentorship team. So I've included a link here to an introduction to Excel, and then we'll work together with our mentors on WhatsApp and through various introductions to the Excel software. We'll talk about Excel in the office hours this Saturday, but if you want to get a head start, you can watch this. It's in English, but you can use the settings to translate everything into French because it does have subtitles. So thank you so much for your attention today, and we look forward to seeing you on Saturday.